Traditional code is slow, expensive, and burdened by legacy debt. At Needlu, we've broken the cycle. We moved beyond manual coding to a metadata-driven architecture, creating a living framework for the future, powered by three core pillars: the architect, the backbone, and the engine. This is more than just innovation. It's a 90% reduction in cost and time to market. This is Needlu. Invest in logic, not legacy.
Enterprise software has a scaling problem. As a system grows, it relies on a massive, monolithic codebase that eventually begins cracking under its own weight. In traditional development, adding a single new feature requires a rigorous, linear cycle. Developers write the logic, commit the code, and then force the system through a time-consuming build cycle to compile those changes. This reliance on continuous integration and continuous deployment pipelines, or CI/CD, hard-codes operational latency directly into the workflow. Every single update becomes a waiting game. Beyond the lost time, there is a physical cost. Compiling millions of lines of code requires enormous computational power, driving up energy consumption server by server. Traditional architecture traps organizations in a strict trade-off. Achieving massive scale dictates that you must accept slow, computationally expensive build cycles. The Needlu framework approaches this bottleneck by eliminating the compilation step entirely. It removes the CI/CD pipeline from the equation. This architectural shift targets two specific metrics: a 90% reduction in capital costs and a 90% increase in project deployment speed. The mechanics rely on shattering the continuous loop of code commits. Instead, the system operates on dynamically interpreted JSON metadata. This connects directly to a fully abstracted application engine, executing requirements on the fly, bypassing compilation entirely. To understand how comprehensive ERPs, systems complex enough to run healthcare and construction enterprises, can operate securely without a traditional codebase, we have to look at the architecture making this abstraction possible. Shifting a system from static compilation to dynamic interpretation solves two distinct problems. It strips away operational latency and drastically reduces the computational carbon footprint of enterprise software. Replacing a massive codebase requires a new structural foundation. This abstraction is divided into three distinct pillars: intelligence, governance, and the universal engine. The foundational layer is the intelligence pillar. This is where the core data flow originates. In this system, specific features are never hard-coded. Instead, business logic is captured as abstract rules. An industry expert observes real-world operations and inputs them into the platform. The platform then transforms those operational requirements into a sophisticated, machine-readable digital blueprint. This digital blueprint is stored as structured JSON metadata. It contains the instructions for the software, but none of the actual executable code. Generating lightweight text files has vastly different computational requirements than compiling a multi-gigabyte application layer, especially when utilizing AI to assist in development. Because the system generates lightweight JSON metadata rather than millions of lines of raw code, the energy required for AI to process and generate these instructions is reduced by over 60%. By proving that much smaller file sizes yield directly lower computational overhead, it becomes clear that abstracting operations into JSON is the primary driver of this system's carbon-neutral capability. The governance pillar acts as a strict security boundary wrapping around the exposed metadata. It enforces role-based access control, dictating exactly which user types can interact with distinct, limited subsets of the JSON data. This layer securely manages multi-tier hierarchies and precise data bounding, functioning completely independently from the core business logic established in the first pillar. Decoupling this governance layer from the intelligence pillar ensures that operational rules and security rules never interfere with each other during configuration. Because the access controls are isolated, a healthcare administrator or construction manager can safely build out complex operational workflows without running the risk of breaking underlying security protocols. At this stage in the architecture, we have secured static JSON. But to be useful, those instructions must be converted into a functional application interface for the end user. This brings us to the third and final architectural component, the universal engine. This is the runtime execution layer. The engine's primary function is dynamic interpretation. It reads the blueprint provided by the intelligence pillar and turns those instructions into actions. Operating as the runtime environment, the engine receives the securely wrapped JSON package from the governance pillar and begins processing the metadata. Instantly, it executes the operations, generates native APIs, loads the required forms, and outputs a complete user interface. All of this UI generation happens dynamically on the fly. The engine pieces together the layout based purely on metadata, relying on zero pre-compiled graphical assets. This entire translation step requires absolutely no code compilation and skips deployment pipelines entirely. The universal engine is the component that transforms a static metadata blueprint into a living, scalable software solution in real time. When we compare a traditional codebase update to dynamic metadata rendering, the difference in latency is severe. Consider the exact millisecond a user interacts with the generated interface, clicking a button to approve an invoice, for example. In that fraction of a second, the engine references the governance pillar to verify the user's role and ensure they have the clearance to execute that approval. Simultaneously, the engine queries the intelligence pillar to find the correct business logic, routing the invoice to the next stage in the workflow. In a traditional environment, this same adjustment requires a full development cycle, writing the code, testing it in staging, and then pushing it through a production pipeline. Here, the update is instantaneous because the engine simply reads a new line of metadata. Furthermore, if thousands of users click that approval button at once, elastic data scaling is handled natively within this rapid cycle to maintain performance. The system also generates native APIs to communicate with external databases simultaneously, requiring zero manual intervention from a developer to wire the connections. The true differentiator of this architecture is defined right here. It handles all structural scaling and API generation natively at runtime without any manual engineering. To see how these theoretical layers unify in practice, let's trace a specific workflow through a top-tier commercial construction ERP system. A manager inputs a new site inspection rule. Pillar 1 converts this logic into a JSON blueprint. In Pillar 2, governance filters attach access permissions. Finally, the universal engine instantly renders this new workflow directly onto the foreman's mobile app. From the moment the construction manager recognized the need to the moment the application updated in the field, not a single software engineer was involved. This specific frictionless data pathway demonstrates precisely how organizations achieve a 90% reduction in overall project completion time. When we zoom out to the macro scale of deploying enterprise solutions globally, the implications of this model become clear. Abstracting the enterprise stack into a metadata-driven universal engine renders the traditional CI/CD pipeline obsolete. This architectural shift yields two distinct measurable benefits: a 90% reduction in project costs and a 60% drop in AI inference energy. The long-standing assumption that massive corporate scale mandates slow, computationally expensive build cycles is no longer accurate. The future of scalable enterprise software relies entirely on the speed and efficiency of dynamic interpretation, rather than the heavy burden of static compilation.
Now we are in the intelligence pillar. So I have given instruction in simple English to create financial transaction form, customer registry, and item registry. So the system will generate three forms here. So you can see the JSON object, and you can see the preview here for the financial transactions. And underneath that, you will see the preview of customer registry and the fields that the system has suggested. You can specifically mention if we need to change these fields, but it's what the system has suggested. So item registry has several fields as well. Now I'm going to save this to my workspace. Furthermore, I have requested another couple of forms: customer invoice header and customer invoice lines. The customer invoice header will have two buttons, release and deliver. Now I have generated the JSON object, and in the preview you will see the buttons I requested: release and deliver. Now you can see the solution here. We just gave the prompt in simple language, and now you have the working software. We are already entering customer registry without any delay. So we are going to save a customer here, customer record. And in the left side navigator, you can see the forms under the finance category here. Financial transactions, customer registry, item registry, and invoice. Those are the forms that we created by just giving the prompt. And now we are going to save the first record in the solution that we have just created. Let's click the button save. Wow, it's saved and it's a working software. So now we are going to enter a few customers and few items and then invoice, and then let's see the transactions. I entered few items as well, and now we are moving to the hot part, the invoice. So we can see the entered customers here in the drop down list, and we save the header. The header is saved, and you can see the buttons release and deliver there. And now we are going to enter invoice lines for items that we have just entered, and the price is fetched and the quantity is set, and you can see the line total and also the total in the header level 45,000, and we enter the quantity here, and you can see the line total and also the updated total invoice amount in the header. And now we just released it, and you can see status is changed, released, and we click the delete button. So that would have created financial transactions. Let's go and see, and we populate the form here, financial transactions, and you can see the transactions. So accounts receivables are debited and revenue is credited for 2 lines. So you can see 4 transactions, 2 for each. So you just witnessed that we created a working invoice within less than a couple of minutes. We did that without any software engineers, no coding, no compilation, just a working software in a couple of minutes. We go to the extent creating comprehensive ERP system, which will be the future of modern software development industry. Thank you very much.